I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we will briefly discuss about the topic problem solving agents in AI. All you know that problem solving agents are a type of goal based artificial intelligence system designed to find a sequence of actions that lead to a desired outcome or goal. These agents operate by formulating a clear goal, assessing the current state of the environment, and then systematically exploring possible actions to achieve the goal. The process involves defining the initial state, identifying potential actions and resulting states, and evaluating the most efficient path based on certain criteria, such as minimizing the cost or time. Problem solving agents are widely used in applications like navigations, robotics, and automated decision making, where the objective is to find the best solution from a range of possible options. We'll see one example, and first we'll go for the introduction about this problem solving agents. So the first, what is the definition for problem solving agent? It is a problem is a goal based agent. How we can explain? A problem solving agent is a type of goal based agent that works by taking actions to transform its current state into a desired goal state. The agent's behavior is determined by the predefined goal and the rules that define how it can move through different states. This type of agent is typically used when the agent's task is well defined and has a clear objective. These agents are designed to find the most efficient or optimal sequence of actions that will lead them from an initial state to the goal state. And what is the purpose of using this problem solving agents? It finds a sequence of actions leading to desirable states. That means the primary purpose of a problem solving agent is to identify a sequence of actions that will bring it from an initial state to the goal state. This process involves evaluating various possible actions and selecting the most appropriate ones to move toward the goal. Problem solving agents are useful in a wide variety of applications. As I've said, from navigation tasks to complex decision making systems. Let us see some classic example. So in this case, we are going to see the example traveling from Arad to Bucharest in Romania city. A classic example of a problem solving agent is one tasked with navigating from Arad to Bucharest in Romania. In this scenario, the agent's goal is to find the best route considering the factors like distance, time, and other constraints. The agent must explore possible cities and routes, evaluate the costs of each action, and determine the most efficient path to reach the Bucharest. So, what is the initial state over here in this problem? Arad is the initial state, and Bucharest is the goal state. Hope everyone understood this problem. So, and next, what are all the key steps to be followed in this problem solving is first the goal formulation, then problem formulation. Goal formulation, what it says means goal formulation is the first and crucial step in problem solving. It involves defining the desired outcome the agent is trying to achieve. The goal must be clear, measurable, and achievable within the constraints of the environment. So, this is the first and foremost thing we have to consider. For example, in a navigation task, the goal might be to reach a specific city. In this example, what is the city it has to reach? The agent arrived to Bucharest is the goal state. The agent formulates this goal based on its current state and the performance measure that evaluates progress toward achieving the goal. And here, how you are going to formulate the problem, and the problem formulation after defining the goal, the agent moves on to problem formulation. This step involves determining the relevant states and actions that the agent will consider while solving the problem. It includes specifying the possible states the agent can be in, say, for example, different cities in a travel problem, and the actions the agent can take to transition between those states, that is, driving from one city to another. The problem formulation also defines the constraints and rules that governs the agent's action, such as the maximum distance the agent can travel in a single action. That is more important. So this graph, what it shows, all you know that this graph is the traveling from this graph only we are going to find out the distance between or cost between Arad to Bucharest. This is the initial state. Bucharest is the, see here, the Arad is over here, and this is the Bucharest. So the example of traveling from Arad to Bucharest in a Romania serves as a practical illustration of how a problem solving agent works in a navigation scenario. In this case, the agent's goal is to find the most efficient route from Arad, the starting city, to Bucharest, the destination city. The problem solving agent would treat this task as a search problem where the agent needs to explore different cities, that is, states, and the possible roads or routes, actions between them. Here, so many possible ways are there. In the graph representation, each city is a node and the roads connecting the cities are edges. The agent begins the node representing Arad, must explore the neighboring cities such as, see what are the Sibiu, Fagares, no, and others through available roads. The graph would show the different paths the agent can take, each with the associated cost such as the distance or travel time. The agent's objective is to find the path that leads to Bucharest, the goal node, while considering the path costs. For example, the agent may have several possible paths to choose from, such as Arad, Sibiu, Fagares, and then Bucharest, or Arad, Zerint. Here, the Zerint is available. Next, where Zerint? See here, it has to go here. Sibiu, Fagares, and Bucharest. The agent will evaluate these paths based on the path cost and select the most optimal one. Typically, what it should choose? It should choose the shortest or least costly route. This graph helps visualize the search space and decision making process as the agent navigates through various states to reach the goal. So next, we'll see the problem formulation. The example of the problem formulation. Let us take the scenario. In this example, the agent is a traveler on holiday in Romania. The starting in Arad. In this graph, you can in the previous graph you can starting in the Arad, and the agent's goal is to reach Bucharest in time for a flight. This scenario is a typical problem solving situation where the agent must navigate through a series of cities to reach its goal. And the goal is the agent's goal is to be in Bucharest, which is a specific, measurable, and achievable target. This goal guides the agent's action as it searches for the most efficient path. And here, what is the problem formulation? In this step, the agent defines the states and actions relevant to the problem. The states are the cities the agent can visit, various cities, and the actions are the route, no, or roads the agent can take between cities. For example, the agent can drive No, the agent can drive from Arad to Sibiu, then to Fagaras, and finally to Bucharest. The agent needs to evaluate each possible route and choose the one that leads to Bucharest in most efficient way. So this is the problem formulation. Next, problem components. Initial. So here these are all the problem components. Initial state, successor function, goal test, and path test. So initial state. The initial state represents the starting point of the agent. It is the condition or location where the agent begins its task. In the travel example, the initial state would be at Arad. This is the first point in the agent's problem solving process, and it serves as the reference from which all subsequent actions are taken. Successor function. The successor function defines the possible actions the agent can take from any given state and the resulting states that will follow. In the context of travel problem from the state at Arad, the successor function might list the possible cities the agent can travel to next, such as Arad to Zerent or Arad to Zibiu. The successor function is a key to determining the agent's next step and guiding its exploration of problem space. Next, goal test. The goal test is a function that checks whether the agent has reached its goal state. In this case, the goal test would check if the agent has reached Bucharest. If the agent is in Bucharest, the goal test would return true, indicating that the agent has successfully completed task. Next, path cost. What is the path cost here? It is the numeric cost action, that is the distance. Is the numeric cost associated with each action that the agent takes. This cost could be based on factors like distance, time, or resource consumed. For example, the cost of traveling from Arad to Zibiu might be lower than traveling from Arad to Timozora. Here, where is the Timozora? It is there. See here. Timosora, depending on the distance or road conditions. Path cost helps the agent evaluate which actions are most efficient and guides its decision making process. Next, what is the search process in this case? And first, we have to define the search process. The search process refers to the steps the agent takes to find a sequence of action that leads to goal state. This process involves exploring problem space by considering all possible actions and evaluating their outcomes. The agent must explore different paths and select one that minimizes the cost and leads to the goal. Next step, what are all the steps to be followed? And the search process involves several key steps. First, formulate goal and problem. The agent must define the goal and problem based on its initial state. Next, search for action sequence. The agent explore the problem space by evaluating possible actions and their outcomes and execute actions. Once the agent has found a sequence of actions that leads to the goal, it executes those actions in the order. And we have to follow a simple algorithm for doing this process. Simple problem solving agent algorithm is a basic framework that outlines how the search process works. It helps the agent systematically explore the problem space, identify the goal, and execute the solution. And this is the algorithm, simple problem solving agent algorithms. So the simple problem solving agent algorithm is a straightforward approach to problem solving. It begins by receiving the agent's percept. So here percept, which is its observation of current environment. The agent then updates its initial state based on the percept. If the agent does not yet have a sequence of actions, it formulates the goal and problem, then searches for a sequence of actions that will lead to the goal. Once the sequence is found, the agent executes the first action and continues until the goal is achieved. This algorithm emphasizes the importance of goal formulation, problem formulation, and search in the problem solving. Very simple algorithm. Next, what are all the assumptions to be made in this agent design? So here the agent designs we are using the static environment. The assumption of static environment means that the environment does not change during the agent execution. No change. This simplifies the problem solving process as the agent can plan and execute action without worrying about unexpected changes in the environment. Next, it is the this agent is the observable. The environment is assumed to be fully observable, meaning that the agent can detect all the relevant aspects of environment necessary for making decisions. This assumption ensures that the agent has complete information about its surroundings and can make informed choices. Next, it is a discrete. The environment is assumed to be discrete, which with the clearly defined states, actions, and outcomes. This makes it easier for the agent to reason about his action and navigate through the problem space. Next, this agent is the deterministic. In a deterministic environment, the outcomes of the agent actions are predictable, not a random one. It is a predictable environment. There is no randomness or uncertainty, meaning the agent can accurately predict the result of each action it takes. Next, well-defined problems and solutions. So first, we have to follow initial state, successor function, state space, goal state, and path functions. So the initial state represents the starting point of the agent where it has to start error. And the successor functions or actions. This we have seen possible actions and outcomes. So it has to start from error, go to CPU, and then CPU from Dimosora, then Dimosora. So it will end. Successor function defines the possible actions that agent can take resulting state. For example, the state in error, the agent could take like go CPU or go Dimosora. The successor function helps the agent to explore the problem space by listing all possible transitions. State space. And here, the state space is a graph that represent all possible state that agent can reach from initial state. It is a visual or a conceptual representation of the problem space and helps the agent evaluate the different path it can take to reach the goal. Next, goal test. It verifies the goal achievement, whether the agent has reached its desired goal or not. In this case, the goal test checks whether the agent is in the Bucharest or not. The goal test returns true, the agent can successfully solve the problem. What is the path cost function? The path cost function assigns the numeric value, as I've said already, to each action agent takes. This value represents the cost of taking that action, such as the distance between two cities. The path cost function helps the agent evaluate which actions are most efficient. Next, how we are going to find out the optimal solution? Path with the lowest cost among all solutions. Optimal path is the one that minimizes the cost of achieving the goal. In many cases, the goal is to find out the shortest or least expensive path to the goal state. The optimal solution is the best possible solution among all the possible solutions in the terms of cost. Next, say for example, if you are taking this example, no, shortest route in the kilometer in the Romania problem, and the step cost is the cost associated with each action agent takes. For example, the cost of traveling from one city to another might be measured in terms of the distance or time. The agent uses the step cost to evaluate efficiency of different actions and to select the most cost effective paths. So, coming into the conclusion, what are all the key takeaways we are taking into account? The problem solving agents used to use structured approach to achieve specific goals by formulating a goal and defining problems, searching for solution, and executing a sequence of actions. The agents are highly effective in applications such as navigation, robotics, and decision making systems where they help automate complex tasks and make intelligent decisions based on predefined criteria. The use of algorithms or well-defined problem components allows these agents to find efficient and optimal solution to wide range of problems. Coming into the conclusion, so thank you for your attention and engagement. I hope the presentation on problem solving agent has provided you valuable insights into how goal-based agents work and processes involved in solving complex problems. So, understanding key steps, algorithms, and components that drive these agents can enhance our ability to apply them effectively in various domains from navigation to decision making systems. By utilizing these agents, we can improve efficiency, optimize solutions, and tackle challenges across wide range of industries and applications. Hope everyone enjoyed this lecture series. The remaining things we'll discuss in the next lecture. Thank you.